Hi everyone, my name is Samzani Brown and I'm a grad student at School of Electrical Engineering and Computer Science at National University of Science and Technology, Islamabad, Pakistan. This presentation is regarding the paper which I have presented at HONET 2020, which is a conference of IEEE. The title of my paper is HHARNet, taking inspiration from Inception and Dense Networks for human activity recognition using inertial sensors. Human activity recognition is an active area of research. That's majorly because of its applications in different domains that include sports, child monitoring, social networking, entertainment, healthcare, etc. Traditionally, computer vision techniques were used for human activity recognition, which has many limitations that includes high operational cost, portability, privacy, etc. But in recent times, a new trend is emerging, that is to use inertial sensors data for classifying human activities, and in particularly the use of deep neural networks is becoming the norm these days. Our paper is also in the same direction. We took inspiration from two image classification architectures for this project. The first one is called Inception, the second one is DenseNet. The speciality about Inception is on every individual input we apply different size kernels or different size filters upon it to get the next feature map. That helps us identify features of all sizes. The speciality of DenseNet is that we concatenate the output of every convolution layer to the layers ahead of it. That makes the availability of all size features available at the end of the architecture, which helps us do better classification. So we combine these two architectures and come up with a new architecture and apply that explicitly for our application, which is human activity recognition. So we have two contributions to this paper. The first one is that we have presented a novel one-dimensional convolution neural network which is inspired by Inception and Dense architectures, and we have evaluated it on two different openly available human activity recognition datasets. Talking about the first dataset, this dataset was collected using Klexi S2 smartphone. 30 volunteers were involved in its collection and it has 6 classes. We have used raw sensor data of this dataset and we have divided that data into 30%, 70% for training, 15% for testing, and the remaining 15% for validation. The setting dataset is by the Wisdom Lab. It also has 6 activities. It has around about 1 million entries in it, and we have also divided this dataset into 70% training, 15% validation, and the remaining 15% for testing dataset. You may see from these two bar charts that both of the datasets are unbalanced. That's why we not just reported accuracy but have also reported precision, recall, and F1 measure. This is the proposed module, which is a combination of Inception and Dense modules, and we named it Inception Dense module. On every input feature map, we are applying 3 different size kernels that are 1x1, 1x5, and 1x7, followed by 1x1 convolutions. And then we are not just concatenating their outputs, we are also concatenating the feature maps or the feature outputs from the previous layers. Making use of these modules, we have come up with a new architecture which is presented in the slide. After every such module, we are making use of 1x1 convolutions to reduce the size of feature map before passing that to the next module. This is inspired from Inception at paper. On the end, we are reducing the number of kernels to exact number of classes, which is 6 in our case, and then applying global average pooling. The reason of going for this approach was to get rid of fully connected layers, which leads to a very large number of parameters. We have noticed that this not just significantly reduced the number of parameters, but it also acts as a regularization technique, and our performance was improved. On the left here is the confusion matrix for the first dataset, and the accuracy which we achieved was 89.44%. This is the overall performance report which shows you the precision, recall, and F1 score for all the 6 classes. This one is the convolution matrix for the second dataset, and the accuracy which was achieved was 95.26%. This slide shows you the precision, recall, and F1 score for all the 6 classes of Wisdom activity prediction dataset. Moving towards the training process, so we have tested with different optimizers, and the final results were RMS seems to perform better for smartphone dataset and ARM perform better for activity wisdom activity prediction dataset. The entire experiments were conducted on Google's Colab with GPU set as the runtime environment. This is the software stack which was used for the deployment and experimentation of entire project. Concluding my presentation, human activity recognition is an active area of research. That's majorly because of its applications in a lot of domains. We have come up with a new novel 1D CNN that is inspired by Inception and Dense architectures. The accuracies which we achieved were 89.44% and 95.26% for smartphone and wisdom activity prediction datasets respectively. Thank you very much.